In this example, we're going to graph this system of linear inequalities. Okay, so we'll go one inequality at a time. So remember that we need 4 pieces of information to effectively graph a linear inequality. So let's go ahead and start with this first one. And the first thing we need to know, I'll go ahead and rewrite this inequality. The first thing we need to know, the slope, and we need the y-intercept, that's second. So let's get those first. So this is already in slope-intercept form, so I know that the slope is going to be the coefficient of my x, which is -1, or -1 over 1, if we write it rise over run. My b is my y-intercept, so that's going to be 3. The third thing, we need to know whether this is going to be a solid line or a dashed line, and a y is less than, so there's not an equal to in there, so it's just less than. So I know this is going to be a dashed line. That indicates that this line functions as a boundary between 2 regions, and the line itself is not included in the solution set. It's merely a boundary. And the fourth thing, are we going to shade above or below the line? And this is y is less than, so we know we're going to shade below the line. Okay, let's go ahead and tackle the second one real quick. We have y is greater than or equal to 1/3 x minus 3. So the first two things, we're going to grab the slope and the y-intercept. This inequality is in slope-intercept form already, so the slope is the coefficient of my x, so 1/3. And my b, or my y-intercept, is going to be -3. Is this line going to be solid or dashed? Well, it's greater than or equal to, so I know it's going to be a solid line. And since it's greater than, I know I'm going to shade above the line. Okay, well, let's go ahead and graph both of these and then look at where we're going to shade this thing. So the first one, your y-intercept is 3, and our slope is -1, or -1 over 1. So we're going to go down 1 over 1. Down 1 over 1, and we're just going to create a lot of points here. And this line is going to be a dashed line whenever I connect the dots. So let's go ahead and put the points on here for the second one. Y-intercept is at -3, and we're going a 1/3 slope, so up 1 over 3, up 1 over 3, or of course down 1 and back to the left 3, and then I'll give them my positive 1/3 slope. So let's grab our straight edge and do both of these. Let's do this one first. We know this is a solid line, we said, so let's go ahead and draw this solid line. And the other one's going to be a dashed line, so let's go ahead and line this up, and then go ahead and do a nice dashed line. Okay. So let's talk about where we're going to shade. When I look at this, I actually have 4 regions here. So the first one, y is less than -x plus 3. So I know here's my -x plus 3, and we're going to shade less than that. So I know it's either going to be in this region or it's going to be in this region. Okay? Sometimes you can put a little x right there to kind of indicate, you know, this region or this region. Okay, let's go ahead and look at the other ones. It's greater than my 1/3 x minus 3. So since it's above that, we know we're going to shade in this region or we're going to shade in this region. Well, this is the region that satisfies both inequalities simultaneously. So we know that we're going to end up shading in this region right here. Okay? So here is the solution then to my linear inequality system.